Hi, it's Mrs. T, and we are going to talk about the atmosphere again in these lessons, in this lesson folder. And we're going to include some additional information about pressure. We're going to start off by talking about pressure, and we're going to add some other variables into the mix, like altitude and friction and the density of the air and that kind of thing, and the relationship of those different variables that cause wind in the atmosphere, because we are going to address additional topics that have to do with atmospheric motion and wind, etc., over the next few lessons so that we can understand the basics about how and why weather systems happen the way that they do. And so this is some super interesting stuff. I have a degree in geoscience from Mississippi State University, where we study atmospheric trends, meteorology, climatology, those kinds of things. And so this is some very fun information, I think, if you are a weather buff at all, and just for a basic understanding of what's going on around us. This is very good information that gives you the ability to stand firmly on the ground, confident in your knowledge of what's going on around us. So let's talk about pressure. Just to review quickly, we do know that in the atmosphere, we break it down into layers or strata. And so those, like for instance, we're in the troposphere right now. That's where the pressure is highest. The air pressure is highest. There's the most weight from the atmosphere on us, weight, because the gases that make up the air in the atmosphere, they have an atomic weight, and gravity exerts force on those molecules and pulls them to the earth, just like we are pulled to the earth from gravity. And so the atmosphere does have a weight, and the closer you are, the lower you are, that is, to the earth's surface, the higher the density and the higher the pressure is, the air pressure, that is. Okay. And so in general, it's a typical thing that we need to note is that when we are higher up in altitude, like on the top of a mountain, in Colorado or something, or in Utah, or any of the really tall mountains that some of you might have traveled to, you might have heard that sometimes people have a hard time breathing. Sometimes people have to have supplemental oxygen. And the reason for that is because the air density is lower the higher you go in altitude. When the air density is lower, the pressure is lower also. Gas molecules that make up the air have more space to move around because the majority of them are being pulled down by gravity, and these are the ones that get thrown up by temperature gradients or pressure gradients. And so the higher you are, the lower the pressure tends to be, the lower the density of the air tends to be, and the lower down to the surface you are, sea level, let's say, the lower down, the higher density of air that you have. When the air has a higher density, molecules are closer together, and that means that it's high pressure. And friction happens when molecules are closer together, because they bump into each other, and when they collide, they bounce off of each other and they hit other ones accidentally. And these kinds of motions, the friction that happens, usually causes a change in temperature, a temperature gradient. I'm getting a little bit ahead of myself there. I'm going pretty quickly. I have a couple of things on my notes page behind me here that I wanted to mention about altitude having low density and low pressure typically. And please note that I keep saying typically because there's a whole bunch of other variables that you have to consider. And the lower down that you are, typically, it has a higher density and a higher pressure. And one of the things that you can do to investigate this a little bit, or the effects that this has just on daily living, is not only the oxygen thing by traveling into the mountains. Your body, maybe your heart rate will increase and you'll have to breathe more deeply or more quickly to get enough oxygen in your lungs that your body is accustomed to. Those white blood cells that need to process that and carry the oxygen for us to the different parts of our body. So Another thing that you should look at is cooking instructions. Years and years and years ago, lots of years ago, you used to be able to go into a grocery store here down on the flatland, down close to sea level where we are, and buy a box of cake mix or something, whatever, Crusties or whatever cake mix that you like to buy. And there would be baking instructions on there and high altitude baking instructions on there, because the way that temperature behaves when the density and pressure is low, the way that temperature behaves is even different. There'd be a different temperature setting that you'd have to have on the oven, and there'd be a different quantity of liquids or eggs or all these different other things. And so investigate that. Look to see, if you, especially if you like to cook, what kinds of modifications would you have to do to the way that you cook and the things that you cook if you lived at, some altitude or something, in Denver, Colorado, something mile high or up, even higher than that, because it affects just our daily living, the air pressure, the air density. It affects our daily living and the behaviors that we exhibit on a daily basis, not just our breathing and our biology, but culturally, other things too. Also, I have as an example something that you could look up and maybe use as a little mini project or something for a reflection journal for this particular set of lectures. Is I've never been to Hawaii, but a very good friend of mine used to be the manager of one of the resorts on the main island in Hawaii, and she would regularly have groups of tourists who would want to go to the beach one day, want to go scuba diving one day, and the next day want to go into the mountains and go snow skiing. Yes, I said snow skiing in Hawaii. And so you should take this opportunity, if you did not know this about our state, the USA, Hawaii, you should look into the snow skiing part of Hawaii, because the reason it's there certainly has to do with the seasons of the year, like we learned in the previous lessons. Absolutely, it has to do with the seasons of the year. However, it also has to do with the altitude, where the air pressure is lower, the air pressure is lower, the air density is lower, and the temperature is also affected by that. And the air masses and the amount of water that an air mass can hold changes with air density. We'll look into that in a future chapter. But rain is caused by this. Wind is caused by these pressure gradients and the friction gradients. So anyway, these two things here that I have on the screen behind me, I put for our information for our fun to research how this topic maybe affects us in our hobbies, in our travel plans, in the things that we do just to live, cooking, just something that we do to live from day to day, and the different kinds of ways we would have to approach these things if we lived at any kind of altitude where pressure gradients and density gradients would affect us in different ways. Okay, so in general, right below those two topics, let's move on. In general, the more dense that an air mass is, the closer together those molecules are, the more friction is going to happen in that air mass, because the molecules are banging against each other, colliding, bouncing off, colliding again. Okay. And that causes friction. And friction, of course, if you rub something together, rub it, you can just do that with your hands, and you'll feel the palms of your hands increasing in temperature because of that friction. Well, that's what happens with air masses also. So typically, this is going to be the qualifier for everything that I say. Typically, when all other things are constant, when there's more density in the air, there's more friction, and it's going to heat up. More friction means more heat. So that's because, things bump together, as I've got written here. And I also have another disclaimer, because I keep saying the word typically, but I've written here, it doesn't mean that cold temperatures can't happen at the surface of the earth where you have higher density and higher pressure. That's not what this means at all. I've just told you that down lower on the atmosphere, here in the troposphere where we exist, most of us, all of us, we have higher density and higher pressure. Higher density and higher pressure. The more pressure, the more friction. The more friction, the more heat. But things get really, really cold on the surface. So this is not the only thing. We, of course, have the angle of incidence of the sun. We have the seasons of the year, the wobbling of the, of the earth, which affects the angle of incidence. And so these variables all cause different patterns to happen with temperature, with pressure, with density. So that's why I keep saying typically, and that's why I have all these disclaimers. Okay, so typically, again, warm air is associated with low pressure because the warmer things are, the farther they want to move apart. They don't want to be close to something because it's heat. If it's really hot outside, you don't want to snuggle up and cuddle with somebody. It's going to transfer too much heat. And so the warmer the air is, the less dense, the less pressure typically. Okay. Cold air is the opposite. You've got molecules moving together, being attracted to each other and shrinking toward each other in cold air. And so you've got high density and high pressure typically in that situation. Okay. Wind comes from those pressure differentials. So when you have high pressure on the bottom and low pressure on the top, you tend to have wind want to bring some of those molecules up. And when you have high pressure at the top, like maybe air comes across a mountain, it gets compressed, it's got high density, maybe it falls down, and then you're going to have that air circulating that way. And so these pressure differentials, and I'm talking with my hands too much. Sorry. Y'all are getting the treatment, getting the Italian grandma treatment with my hands here. But that's one of the reasons why I want the animations in the videos that I've curated for you. So you don't have to have me, making pictures with my hands in front of my face. But wind is created in part from the friction of the molecules. Certainly wind direction is affected by the friction and those molecules colliding, but also wind direction is influenced by those pressure gradients. If you have high pressure here and low pressure here, you're just like osmosis, that chemical function, that chemical process that you've learned about in biology class or chemistry class. Osmosis has, like, for instance, if there's salt water here and regular water here, you're going to have that you're going to have the salt, spread evenly throughout in that osmosis process. That's what wind is going to want to do. The molecules in the air is going to want to do that. They're condensed over here with high pressure. They're going to want to move to an area, even that out. And that makes wind happen. Friction makes wind happen. The Coriolis force that we learned about the last time in our lectures on the atmosphere in the previous lesson folder. The Coriolis force of the Earth's rotation is also going to affect wind direction. We will see that in some of the animated videos that I have curated for you for this unit. Okay, and so yes, I'm going to post this document that's behind me. I'm going to post this for you in our content folder. And so you have it to refer to. You can add more information. You can ask questions. You can cite it. You can refer to it in your reflection journal or use it as a resource for your unit assignments when they call for this information. So this will be for you in our Blackboard folder. And pay close attention. I will try to have my arms like taped down next time I do a lecture for you, so I'm not waving my hands in the air constantly. But look at those curated videos, the animations, take notes, fill in the gaps here, and add information to the bullet points that I've provided for you in this file. Text me with questions. Look in our module folder for unit assignment 1. I hope you'll have fun with that, and let me know if there's any comments or questions or modifications or anything like that that you need or want. And I will see you in the next video. Don't be a stranger. Bye.